Again, welcome to CS 332 class, operating system. In this lectures, we're going to focus on system calls. So again, our main objective is to go through what is a system calls and also types of system calls. Also, we're going to discuss various ways of structuring an operating system. So first here, we say a system calls normally provide an interface to the service made available by an operating system. So we know in our operating system, we have two modes where program can be executed. The first is the user mode and also the kernel mode. The user mode normally have no access to computer resources such as the CPU, the memory, devices, etc. So if we are executing a program at user mode and the program need a resources such as memory, we need to request a service from the kernel mode. Normally we call the kernel mode the privilege mode because it has access to the computer resources. So if we are executing a program in a user mode and we need any computer resources, we need to request a service to the kernel mode, and the kernel mode will provide the service. Now, the process of switching from user mode to kernel mode is what we call the context switch. So here we say a context switch is switching from user mode to kernel mode, or from kernel mode to also to user mode. So anytime we're executing a program in a user mode and we need the computer resources, we need to again switch the mode to kernel mode. Now the process of switching from user mode to kernel mode and requesting for a service such as computer resources is what we call the system call, the request service. So here we say that when programming need access to resources in user mode, it may request services from the kernel mode. And also a system call will be the programmatic way in which a computer program requests service from, again, the kernel mode. So that's the whole concept of a system call. When we are executing a program in the user mode, most likely we will need the computer resources. We will request service from the kernel mode. And the process of doing that is what we call the system calls. And also we should know the meaning of the term context switch, which is again switching from user mode to kernel mode or kernel mode to user mode. So normal operating system have these two modes where program can be executed, the user mode and also the kernel mode. Now, the good news is that user mode is very safe. The reason why, because the program executing in a user mode doesn't have direct access to computer resources. So if there's any fault or error and the program crash, it cannot crash the whole system. The system will not crash. But in kernel mode, if there's a fault in the program or there's some error and the system have to crash, again it will crash because it has access to all the computer resources. So normally we say the user mode is the safe mode and the kernel mode is not a safe mode. So here again, we said that the programming interface to the services provided by operating system is what we call the system calls. So normally system calls are written in C or C++ language and mostly can be accessed by programs through the high-level API, which is the application program interface, rather than direct system call use. And so we know different types of operating systems have the different APIs. So example, the three most common APIs are the Win32 API for Windows, and also POSIX API for POSIX-based systems, which include the Unix and Linux, and also the Mac OS also, X. Then we have the Java API for the Java virtual machine. Also, we should know that the system calls we are going to cover in these lectures are just a generic names. We're also going to discuss about different types of system calls. So this is an example of a system call Here we have a system called sequence to copy a content of one file to another file. So if we are executing this program in the user mode, again, we need access to the storage device or IO device. So we must request a service, which will be a process of the system call. So an example of system call sequence. First, again, we are copying file from one location to another. So we are going to acquire the input file name first. Then when we get the file name, we are going to write a prompt to screen to accept the input. Then next, we're going to acquire the output file name, where we are going to again save the file at or location, destination. Then we're going to write prompt to screen and accept the input. Next step is to open the input file. If the file doesn't exist, then we are going to abort. If the file exists, then the file will be open. So we're going to create the output file if it exists. Then since again, a file consists of a sequence of information data, we need a loop. So we're going to read from the input file, then we write it to the output file. So here we say until the read fails, we're going to close the output. So again, this would be an example of a system calls. Here we can see that there's more than one system call. So a typical program can even request over thousands of system calls. So this is an example of a standard API or application program interface. Here we have a program that we are going to consider the read function that is available in Unix and also Linux system. So the API for this function is obtained from the man page by invoking the command man read or man read. So on the command line, this is the description we have for the API. First, we have the returnee type or the returnee value of the function read, and the function takes a parameters, and we'll go through each of these parameters. Now, in order to use the read function, we need to include our header files here, the Unix standard header files. So here we say a program that uses the read function must include the Unix standard.h header file or the standard header file. And this file defines the size t, size t, and also size t data types, among other things. And the parameters, again, the fd is the file descriptor to be read. So the first parameter of the function, the file descriptor. Then second, we have the buffer where the data will be read into. And the third will be the maximum number of bytes to be read into the buffer. So next we talk about the system call implementation. And here we say typically a number are always associated with each system call. So a system call interface maintains a table index according to these numbers. As we said earlier, again, one program execution or one task execution can create many system calls in sequential order based on the algorithm, the steps. So normally a system call interface invokes the intended system call in the OS kernel. That's the operating system kernel, and then return the status of the system call and any returning values. So now a caller needs to know nothing about how the system call is implemented. Just need to obey the API and understand what the operating system will do as a result call. And most details of operating system interface is normally hidden from the programmer by API. So this is an example here. As we said earlier, always operating system have two modes. So we have the user mode at the top, the kernel mode down. And then we have the user application. And the user invoke the method to open a file. Now, to open the file, we need to have access to the storage place where the file is located. So that will be an IO device. So this means we have to send a system call request. So here we have the system call interface, and this is the request to the kernel mode to open the file. And in this case, we're going to have access to the file and the storage place. So often, more information is required than simply identity of desired system call. So again, the desired type and the amount of information may vary according to the operating system and the calls. But we have a 3 general method that we use to pass parameters to operating system. And the first one is the simplest one, which is pass the parameters in registers. Normally pass the parameters in register. In some cases, maybe more parameters than registers. And also parameters stored in a block or a table in memory, and also address of a block passed as a parameter in the register. And this approach is normally done by Linus and Solaris. Also, parameters placed or pushed onto the stack by the program and pop off the stack by the operating system. So we may have a block and stack method, which do not limit the number or the length of parameters being passed. So example, parameter passing through a table. So here we have the register. We have a parameter for a call X. So we load the address X into the register. And then the system calls. Here we identify the system call as 13, which we use again the parameters from the table. So here we have the user program and then the operating system. So next is the type of system calls. As we said earlier, we have 5 different categories of a type of system calls. The first we go through will be the process control. So we know in process control, the whole concept is how we control our process. The process is a program that is in the execution mode or is executing. So first, we know one of the functions will be to create a process. And that is to create a process or to terminate a process. Then the next can be, we can end the process or abort it. Abort normally will happen if there's an error and the process didn't finish. Then also we can load the process. We can also execute a process. We can get the process attributes, and also we can set the process attributes. And sometimes if the process is being used or there's a time, we can go for wait for time or wait event, signal event, allocate, and free memory. Dump memory if there's error, or debugger for determine bugs, single step execution, and also logs for managing access to shared data between the process. And I'll say the major process control is creating the process, terminating, ending, abort. We should be able to load the process, execute, and get the process attribute, set the process attribute, and wait for time. The next will be the file management. And in process of file management, again, we can create a new file, we can delete a file, we can open an existing file, we can close a file. All these tasks, again, since file is located, saved in a hard drive or a storage device, in a user mode, we don't have access to the storage device. So these are all system calls, functions, or programs that we can use to request service from the kernel mode. So if I want to access a file, or I want to create a new file, or we want to read a file, write, or reposition the file. Also, if we want to get and set the file attributes. Then the next will be the device management. So a system call to request for a device. It can be input device, output device, the CPU, any device. Also, when we use the device finish, we need the system calls again to release the device or read and write and reposition the devices. We can also get the device attributes, set the device attribute, and logically attach or detach the devices. We also have the information maintenance to get the time or date, set the time or date, get the system date or system data, get the system data, and also set the system data. Also, we can get a set process, the file and device attributes. Then we have a communication. So here also we can create a communication connection or delete a communication connection, send or receive message, if message passing model to host name or process name. This should more or less be a networking system, client and server communicating. Also share memory model, create and gain access to memory regions, transfer the status information, attach and also detach remote devices. And the last will be the protection, which is our sixth one. So here we can control access to resources, such as setting the privileges or what resources a specific other user or program can access. Get and set permissions, mostly for users, and also allow and deny user access. So in summary, these are examples of Windows and also Unix system calls. And we have the Windows on the right. So for example, the process control, we have a Windows program or a function that can create a process, exit a process, wait for single object. Now in Unix, we mentioned this in our earlier lectures. In Unix, we call the fork to get a process and to create a process. Now, if you want to exit in a process, we have exit function or wait to wait for single process. And so this is the summary file manipulation. We can create a file, read file, write file, close, undo. Normally, when we create a file, we have a file handler that we use more or less like object to access the file, reference to the file. So with Unix, the function is open, read, write, and close. The same thing with the device manipulation. We can set the console mode, read the console, and write console. Information maintenance, we have with Windows, to function to get current process ID, set a timer, sleep. With communication, we can create a pipe, create file mapping, and also map view of file. So we also have the standard C library, especially the Unix. So for example, here, C program that is invoking printf library call, which calls the write system call. So we have the C language, the standard input, output, header file, the main method. We have all the code, but in our case here, again, we are invoking the printf, and this will print and greetings. So this C program is invoking the printf library call, which again calls the write system calls. So we have our, again, this is our interface and system call interface. We have the user mode and the kernel mode. So again, the user mode is where we write our code. But now, in this case, I want to print something. Even if I want to print it on the screen, or if I want to save something to my computer, we still have to request the service from the kernel mode, since the kernel mode have all the hardware resources, the memory, the storage, the CPU have access. So here we are using the system called write function that will do the job for printf. So next we talk about system programs. And here we say system programs normally provide a convenient environment for program development execution. And operating system is a system program, which again provide a convenient environment. And most important with operating system, it interacts with the computer well, control the computer hardware resources. And here we said system programs can be divided into the following. We can have the file manipulation. We can also have the status information, sometimes stored in the file modification. Also, we have the one that normally support the programming language or program loading, execution, communication, background services, and application programs. So most users, again, view of operating system is defined by system programs, not the actual, again, system calls. So we can see all these functions, again, can be handled by operating system. So again, operating system is a system programs. So it provides, again, a convenient environment for program development and execution also. Now, if I'm writing a program for Java, I may have a Java IDE, integrated development environment. But when I compile the program, again, I'm requesting service from the kernel. I may write a source file in my user mode. Normally, we always do our work from the user mode. But when we need a service, such as memory or computer resources, then we have to request the service from kernel. This is kind of, again, a safe method of computing environment. So file management also, as we said earlier, we can create, delete, copy, rename, print, dump, list, and generally manipulate files and directories. The status information can be, some asks the user for information such as date, time, or amount of available memory, and the disk space we have in our computer, or number of users online if it's a networking system. All these, again, operations are provided by the operating system, all these tasks. Also, others provide detailed performance, the logging and debugging. Also, the file modification, such as text editors to create and modify files, and also special command to search content of files or perform transformation of text. Then, as we said earlier, compilers, programming language support such as IDE, integrated development environment, of compilers or the assemblers, debuggers, etc. Also, we have the background services such as launch at the boot time, some for system startup, and some, again, from system boot to shutdown. One thing we should know about application programs that don't pertain to system. An application program are normally run by users, such as Microsoft Word, Excel, etc. Not typically considered part of operating system. So if I use Microsoft Word to create a document, let's say a resume, if I want to print the resume, again, Microsoft Word cannot directly access the printer. So we must pass through the operating system. And the operating system kernel may service do the task for us. So that will be the conclusion of these lectures. Again, our main focus on these lectures is what is a system calls and how, again, it works, different types of system calls concept. So again, wish everybody the best. If you have a question, again, you can send an email or you can reach me at my number, and wish to see everybody in class. Thank you.